You know, black holes, they are the universe's ultimate abyss. We're talking about objects with gravity so powerful, so intense, that literally nothing, not even light itself, can get away. They're terrifying, for sure. They're deeply mysterious, and they lead to one of the most incredible thought experiments in all of physics.
So let's just go there. What if you actually did it? What if you decided to take the ultimate plunge into one of these things? Well, that's what we're going to unpack today. We're going to piece together that whole journey, from the edge of oblivion right into the heart of infinity. So, let's dive in.
But here's the thing, and it's a big one right at the start. There isn't just one simple answer. It turns out the experience of falling into a black hole isn't some single, straightforward event.
No, it's actually a paradox. It's a story that has to be told from two completely different perspectives. And depending on who's watching, you or someone else, the fundamental rules of reality, we're talking space, time, your very existence, all of it changes. All right, so let's start this wild journey. The very first decision you've got to make, and believe me, it's the most important one, is picking your destination. Because, believe it or not, the size of the black hole you fall into is going to have a dramatic effect on your immediate fate. So look at this. Here are your two basic choices. On one hand, you've got your stellar mass black hole. The problem here is that the tidal forces at its horizon, which is pretty small, are just extreme. You'd be ripped to shreds before you even got inside. But then you have the supermassive ones. Their horizons are so vast that the tidal forces are actually pretty gentle. So the takeaway is clear. If you want to survive the initial fall, you have to go big. And that pretty gruesome process of being torn apart, it has this weirdly playful name, spaghettification. Just try to picture it. The black hole pulls on your feet so much harder than it pulls on your head that you're just stretched out into this long, thin strand of atoms. It's like the universe's most brutal pasta maker. And with a small black hole, this all happens before your journey even really gets started.
Okay, so you made the smart choice. You picked a supermassive black hole. You're getting closer and closer to the event horizon. That is the literal point of no return, and this is where things get truly bizarre. This is where our two different stories start to fly in completely opposite directions.
So what actually goes down right at that boundary? Well, the answer depends entirely on your point of view. Are you the unlucky astronaut falling in, or are you the one watching safely from a distance? Okay, let's say your friend is watching from their spaceship, right? As you get closer to that horizon, they'd see the immense gravity just warp time itself. To them, your clock would tick slower and slower and slower. The light from your suit would stretch out, shifting towards red, getting dimmer and dimmer, until you just freeze. You'd look like an eternal, ghostly image stuck right at the edge. From their perspective, you never, ever cross inside. But for you, it's a completely different story. There's no dramatic moment. There's no wall. There's no barrier. You just float across the event horizon. You wouldn't notice a thing. 1 second you're outside, the next you're inside. It's a perfect example of Einstein's equivalence principle. For you, the fall just keeps going, totally uneventful. But now you are past the point of no return. There is absolutely no way back. So you're in. You've crossed the threshold, and now you're inside the black hole. This is a place where the fundamental rules of the universe are just rewritten. Here, the very concepts of space and time start to trade places.
I absolutely love this quote because it captures what's happening perfectly. See, out here you can move wherever you want in space, but you're always being pushed forward in time. Inside a black hole, that flips. Now, every possible path, every direction in space points to one single place, the center. The singularity isn't a location anymore, it's a moment in your future. It's just as inevitable as tomorrow.
So what would you even see in there? The very fabric of space is flowing into the center faster than light, and it's dragging you along for the ride. If you looked back, you'd see the entire future history of the universe play out, speeding up and contracting into a single, blindingly bright point of light. But ahead of you, there's nothing. Just the absolute darkness of your final destination.
So your personal journey is, well, it's nearing its end. But for physics, this is where the real headache starts. This is where the biggest problem begins. Your little trip has created a paradox that pits the two great pillars of modern science, general relativity and quantum mechanics, against each other in a battle for the soul of the universe. Okay, so here's the fundamental clash. Einstein's general relativity says that you, and all the information that makes you, every memory, every atom, gets crushed out of existence at the singularity. Poof, gone forever. But quantum mechanics has a core, unbreakable law.
Information can never, ever be destroyed. It has to be conserved. So which one is it? Does the black hole delete you, or does it save a copy somewhere? To solve this, physicists have come up with some truly wild ideas. I mean, listen to this. The holographic principle suggests that all your information gets painted onto the 2D surface of the event horizon, like a cosmic hologram. Then there's the firewall paradox, which says you just hit a wall of pure energy at the horizon and get vaporized instantly, releasing your info back out. Or maybe black holes are fuzzballs, tangled messes of string with no real horizon at all. The thing is, every one of these wild ideas creates its own new set of problems. It's like we're pushing right up against the edge of what we can even comprehend.
So, you might be thinking, why do we care so much about this morbid thought experiment? Because it is so much more than just a sci-fi horror story. It is actually one of the most powerful tools we have to probe the deepest laws of nature. It's because a black hole is a cosmic laboratory. It forces our two best theories of the universe, relativity and quantum mechanics, to break down. It forces them to confront each other. And by trying to figure out what happens in this ultimate, extreme environment, we are forced to search for something deeper, a new theory of reality, what physicists call a theory of quantum gravity.
And that really brings us to the biggest question of all. Look, your fall into a black hole might just be a story we're telling, but the paradox it uncovers, that's one of the biggest, most real mysteries in all of science. It points the way to the next great scientific revolution. So, what secrets about space, about time, and about information itself are just waiting to be discovered inside that final, silent singularity?